right? I think you should take note of this. The first shell can hold 2, the second shell 8, right? The third shell 8, and then the fourth shell 8. So these are the maximum the shell can hold. As I said before, when you move on to higher level, you learn about 18, then 32, stuff like that. But at this level, just need to know about this for now. When you learn about SPDF notation, but you don't have to worry about that. So the first shell hold 2, second shell 8, third shell 8, and then the fourth shell hold 8 as well. Because we're not gonna go over we're not gonna go over more than 4 shells at this level. So the fourth shell can hold 8. So just take note of that, Morgan.
Yes, sir.
I would prefer you write it down. I would prefer for you to write it down. But either one works for you if you want to screenshot. And also remember that all the videos, right, post it on the YouTube channels. So we're building that YouTube channel as well, so you can watch all the videos, right? If it is that you have problems with a topic, you can rewatch the videos on YouTube. Ready, Marvin?
Yes, sir.
Alright, let's continue. Hold on a minute. Alright, good. So steps in drawing shell diagrams, right? Because we're moving into that pretty soon. So the first step, you're gonna determine, right, the protons, neutrons, and electrons in the structure using the atomic number and the mass number. We know how to do that, right?
Yeah.
Good. Which is the same. So you see how many times we're gonna use this formula. A equals Z plus N. So that's the first step. We're gonna determine the protons and electrons using the formula. Protons, neutrons, electrons. As I said before, right? Once you know the amount of protons, right? The atomic number tells the amount of protons as well as electrons in the structure of the atom, which is gonna result in the overall charge to be 0. Both of them are equal. Remember, the charge on protons is positive, the charge on electrons negative, and then the charge on neutrons neutral. So both these two will contribute to the overall charge. So once they're equal, both of the charges are going to cancel out each other, which is going to make the overall charge on the atoms neutral. If I'm missing a particular point, just tell me to hold on, go back over. So just let me know. Let me know if you get a particular part. The second part, the second step, you're gonna draw a small circle for the nucleus. So it's not, so this is right here, can take out. So you're gonna draw a small circle for the nucleus and write the number of protons and neutrons in the nucleus inside the circle, which would be something looking like this, as you always see me drawing. You have N and P. So after you work that out, using the mass number and the atomic number of the symbol that you're seeing on the periodic table of a particular element, you're gonna now go ahead and determine the protons and neutrons using the same formula above. After you determine that, now you're gonna write the amount of protons and the amount of neutron. So for argument's sake, just using an example, you work one out, right, and you get 5n for 1, just for argument's sake. But not argument, for demonstration's sake. And then you have 5p. So what you normally do, after you work that out, using this formula, you're now gonna write the number and beside the n and beside the p. Do you get that?
Yes, sir.
You sure?
Yes, sir.
All right. Then you're gonna work out the electronic configuration by filling up the shells with electrons in order. So I'm gonna, you don't need to worry about this. I'm gonna explain. So you work out electronic configuration by filling out the shells with electrons. So the idea is that you have to ensure that each shell is filled before you move on. So remember, the first shell can hold a maximum of 2. Second shell,
8.
8. Good. Third shell, 8. And then the fourth shell, 8 as well. So if it is that, for example, for the second shell you get 4, you can't move on unless it's filled. However, you have to ensure that you're gonna fill it, you're gonna work with that using the amount of electrons in the structure. So for example, you work out the amount of electrons to be 6, right? The first shell, you ensure that the first shell is filled, which would be 2, and then the second shell would be 4, right? Because 4, 5, 6, you can't do anything else, because this is the amount of electrons that is present in the structure. So it's not a case where you're gonna say, all right, 2, 4, or 2, 8, and then you just randomly add numbers. It's not a case like that. You have to ensure that you work based on the amount of electrons that you find or that you work out to be in the structure of that atom. Say if the atom has 6 electrons, right, you have to show the 6 electrons into it. Has to add up back to the 6 electrons, which would be 2 and 4. So the first shell is already filled, right? So it can't hold anymore because it can hold a maximum of 2. So the second shell now can hold the 8. The second shell can hold the 4 remaining of the 6 that you have, because it can hold a maximum of 8. Are you following, or should I go over that section?
Sir, but okay, I understand.
So as I mentioned, the first shell can hold 2. So once you write the 2, right, you move on to the second shell and you write the amount remaining. You get that?
Yes, sir.
If we have any more here, and then we can work out some on the blackboard. So let's clean out what we have. Now represent the electric configuration by drawing circles around the nucleus. You don't have to worry about the concentric circles. You don't have to worry about this word concentric. Don't worry about it. Just draw circles around the nucleus. Now use cross or dot to represent electrons, right? I did a video on that as well on the YouTube channel, showing the difference between dot and cross. So just to summarize, this would be the cross. So you're gonna use either to represent the electrons on the structure. So you see, so this would be dot, this one would be dot, and then the top one would be cross. So this is basically how these are the symbols that you use to represent electrons. So you can use either one. You can use a dot or you can use a cross. You get that?
Yes, sir.
Let's draw it properly. So that just like a full stop, right? And then the cross, similar to the asterisk.